Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap with some really useful information, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it on demand. Following today's presentation, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our panelists, please don't wait, don't hesitate. Go ahead and use your GoToWebinar control panel, submit your question, and we'll take as many as we can near the end of the presentation. And finally, we are doing a a drawing at the end of today's presentation for 5 $50 Amazon gift cards. So please stick around. And as I said, near the end of today's presentation, we'll be doing that drawing. Hopefully you'll be one of the winners. All right, with that, we're going to go ahead and kick off today's webinar, which is a graph-based approach to hunting zero-day vulnerabilities in DevOps pipelines. Our speaker today is Chetan Conikee, who's CTO and co-founder of ShiftLeft. Hi, Chetan, how are you?
Great, Charlene. Good afternoon, good evening, good morning to all of my attendees. Thank you very much for taking your time. And without further ado, I'd like to get started. Our topic for today's discussion is a graph-based approach to hunting zero-day vulnerabilities in DevOps pipeline. Every company is writing software, and much of it is deployed in the cloud. In this world, attackers are leveraging applications as the conduit to the all-important data that is representing your business. The unit of value is software or code, because this code is compiled and an application is created and deployed in production to serve your business needs. ShiftLeft has the best understanding of your code and its modern interpretation to help developers identify what needs to be fixed from a security perspective. Hence the name ShiftLeft. In today's webinar, we'll discuss the following topics: source code, which is your unit of value. The next is what is code property graph and its applicability to your unit of value. Thereafter, how can we query code property graph to hunt and identify vulnerabilities, business logic flaws, insider attacks, and data leaks that might lie in your application. Source code is typically written in any programming language, but they have a few common traits. Those traits are, there are a minimum sequence of characters or tokens that have some meaning, just like a spoken language, represented by alphabets of the programming language grammar. In adherence to this language tokens, it can be combined to represent a statement like let A is equal to B, or let Q is equal to X plus Y. These statements can be assignments, branches, controls, and conditional evaluations as well. Conditional evaluation examples are if X is equal to true, then do something, else do something else. When you combine multiple statements together, we create a basic block, which essentially becomes a function. And these functions have entry and exit points. Like you see in the screen, we have functions called as name, can pay, spender, etc. Now, as multiple functions connect with each other and pass data in lieu of communication to create a data flow in order to serve a certain business need. As you might imagine, graphs can relate to programming in a variety of ways, because what you see on the screen is a multitude of functions communicating with each other with a certain workflow. And graphs do an excellent job of depicting how elements in your code base depend on each other. You can use them for methods, types, namespaces, assemblies, etc. And in any of these contexts, they provide an excellent window into the architecture and maintenance profile of your code base. Now, as software systems are composed of many interacting elements. A natural way to abstract over these complex relationships is to model the application and its communication paths between its open source dependencies and the frameworks it's connected with using a connected graph. And being an evolving system, an application's entire graph evolves over time, mostly growing and increasing the number of nodes and edges. Owing to this, it becomes relatively hard to assess and comprehend the security posture of your application. Upon grokking at the screen, you notice that there are several communication paths. And if you're using tens and hundreds of open source libraries and deploying on a framework, this whole process of understanding your code becomes fairly unwieldy. So upon grokking this complex composition that you see, can we answer the following questions? Is your application compliant and treating sensitive data with care? Can authentication logic be bypassed in this code composition so that an attacker can abuse a business logic flaw? And if you're using tens and hundreds of open source library, is these open source libraries used in a safe or unsafe way? And is your application at risk of insider attacks? Note that I posed just a few questions, but there's several other questions that could lead to your risk profile of your application, which means if you deploy your application in production, you're at the risk of this application being attacked by a hacker. Fear not, the all-encompassing code property graph is here at your rescue. This is an invention of our chief scientist, Dr. Fabian Yamaguchi, and the core foundation of ShiftLeft. The code property graph is essentially a versatile graph of graphs, depicting connectivity of the entire application fabric and all of its piece parts, meaning all the open source libraries it consumes and the open source framework upon which it is deployed. The CPG, or code property graph, creates a multi-layered three-dimensional representation of the code's call graph, which encompasses data flow, configuration, which in its entirety provides unprecedented insights that enables code developers and analysts to fundamentally understand the application security posture. The CPG details include representation of the raw programming language, meaning if you write code in C#, Go, Java, etc., all of that code is represented in this uniform format, covering all of the open source it's using and the SDKs or platforms upon which it is deployed. After creating this composition and graph, we can extract what we call as high-level information flows. Inspired by Unix or Linux file descriptors, the idea is to mark parameters for sources, because typically in your application, you accept inputs from your consumers. Those are sources. And as your application communicates with databases and writes to file systems or communicates outbound over a WebSocket or HTTP to other microservices, those are quantified or annotated as sinks. And then between sources and sinks, there is transformation and validation happening, meaning when you accept an input from a consumer, you validate that user. And then you check for certain criteria on all input applied to the source before it touches a sensitive sink like a database or a file system. So a web application is an integral part of today's web ecosystem that enables dynamic information and service delivery. All of us are writing web applications to serve our business needs. On the server side, the web application receives user input via HTTP requests from the client and interacts with various resources or sinks like file system, a backend database, or components for information retrieval. And as that information is retrieved, an output is created and a response is sent back to the consumer. These web applications get increasingly complex to support sophisticated business functionalities, owing to which a new class classes of vulnerabilities have emerged because engineers write code really fast, and DevOps pipelines with agility lets the engineer deploy the code even faster to production. With this fast velocity comes the risk of attacks. And today we're going to be speaking about different kinds of attacks. The first class that we'll cover are common vulnerabilities, categorized by the OWASP category. And the next kind, which we refer to as business logic attacks, have attracted increased attention in recent years. Logic attacks are radically different from common vulnerabilities, which are what we call as input validation attacks. Input validation attacks manipulate the syntax of the web request to generate a malformed input, which essentially tries to take control of your application. While business logic attacks are disguised as syntactically valid web requests that carry malicious intentions to violate your intended application logic. The admins amongst you attending today will be unsurprised to discover that more than a quarter of time, data breaches and information leaks across the world originate between the chair and the keyboard of organized insiders. The latest edition of Verizon's data breach investigations found that 25% of all attacks over the year were perpetrated by insiders or employees of your own organization. And the reason is that they're either disgruntled, or they have a financial gain, or perhaps they have an espionage reason, or it could potentially just be simple mistakes or misuse. ShiftLeft Ocular is an interactive query engine over this graph, this composite graph that we have created, that lets advanced security teams query their code to identify all of these use cases that we spoke of, which are vulnerabilities, data leaks, insider attacks, and business logic flaws. Let us demonstrate the ability of Ocular to use certain examples in order to identify these use cases that we speak of. But prior to that, we'll take a quick tour of Ocular to speak of certain cases to query your code. Very quickly, I'm going to switch to my prompt. The first action that I'm going to conduct is download this code that we just spoke of. I'm going to use the example of a particular open source code called as Tarpit, which has inherent vulnerabilities embedded in this application. In order to guide our thinking, the first step of action is to compile this application. I'm going to use Maven package in order to construct a war or a tar file to represent the compile or build artifact. Now the next step is to create a graph, the code property graph that we just spoke of. And in order to create this code property graph, I'm going to use a simple command called as Java to CPG. This command takes as input the war file that we created, and as an output, it creates this composite graph representing the entire application and all of its dependencies, along with the open source framework upon which it is deployed. So in less than a few seconds, a graph is created to represent your application. Now, I'm going to drop console into Ocular, which is the query engine that lets us ask questions over this graph. Note that this graph is a security representation of your entire code corpus that we're speaking of. And Ocular is a command line tool that we'll use to guide this demo. I'm going to quickly import a series of recipes. And the first action that I'm going to conduct is load the code property graph that we just created. As the graph is loaded, now we have the capability of asking questions of the graph in scope of this interactive session. Given that the graph is loaded, the first question that I'm going to ask is list all the dependencies that we have in this application. Now with a simple API, get dependencies, I have a list of all dependencies, which are open source dependencies used by the application with its associated version. Again, with a simple command, I can filter and ask a further question if we are using a certain type of dependency. And in this case, apply a filter function and checking if the list contains a dependency with the name Jackson. Note that I'm using the name Jackson because Jackson DataBind is a very popular JSON parsing library, which is fraught with deserialization vulnerabilities. And this particular version 2.8.7 is marked as vulnerable in CVE and NIST databases. So using this very simple API, you can verify across all of your code bases of whether you are using a vulnerable open source library and take that information back to your engineers to either upgrade that library or mark this release as a risk. Now, the next question that I'm going to ask is, give me all the types defined in the code. Given that as we write code, we define types. Those types are user-defined types or language types, which are system-defined types. Now, note that by calling this simple API, which is cpg.typedeco.fullname.list, I get a list of all the types used in this application. Note that they are very interesting mix of types here. And merely by examining this list, you can quickly identify what is the code actually doing. In this case, there is a type called as zip4j, which means that the code is most likely unzipping any input received from a consumer. There is a cipher output stream used as well. So we're essentially doing some degree of crypto with our secure data associated with the code. Now we're going to further drill in to identify all literals or hard-coded elements in the application. Most often we log, and as we log, we effectively are sending messages to the log file. So in this case, I'm using an API called as cpg.method.literal.code. Again, a very fluent API. And what I get a list of is all hard-coded literals of strings in the code. Now, this is very interesting because if we see too many hard-coded elements, it most likely implies that we are not UTF compliant from a code base, which means that we cannot apply internationalization on this code, which is also not a security issue, but perhaps a design faux pas. The other danger that exists in code is often when we code really fast, there is a tendency that we might be hard coding cloud credentials in our code. And imagine if we hard code AWS keys or secrets and check into GitHub and open source our code, we are most likely at the risk of an attacker using our keys to compromise our entire cloud account. So let us ask another question to see if we have any such hard-coded elements containing AWS keys in the code. So I'm using the same method, which is cpg method literal, but here I have a pattern which is defining an AWS key expression. And it most likely implies here that there is a hard-coded AWS credential in the code, which is not good. Now I'm going to further ask if there's an AWS secret in the code. And lo and behold, yes, the engineer has mistakenly coded and left behind an AWS secret and AWS key, which is definitely not good. Now let us further ask which method of that code has this particular AWS key coded. For this, I first ask for the literal and further define the method and get the full name. So in this case, there is a particular function called as doGet in a package servlet tarpit. So let us quickly just glance at that Java file in this code. And here it's evident that the engineer has hard-coded AWS credentials, which is not good. And even worse, he's logging these AWS credentials to the log file. So here you are at the risk of exposing these keys to the administrator of your system. And if this code is checked in the open source, you're most likely at the risk of your cloud credentials being compromised. Now let us go a step further and ask, what are the sensitive data elements that we have defined in this code? Note that this is a key value proposition that you otherwise wouldn't find in any other security tool. I'm going to quickly import this script and ask this question. But to give you a sense of the sensitive data elements, it encompasses all user-defined elements in your code. So I'm going to quickly navigate to the code base to give you a sense of what the sensitive data element is. At ShiftLeft, we have devised a technique using natural language processing and machine learning to identify all things sensitive in your code. So in this case, we have a user-defined type, which is of class user, containing first name, last name, passport number. So by glancing at how engineers name these variables, we classify this object as sensitive and then further examine how this object is treated within your code. Now I'm going to ask the next question to identify all API endpoints in this code. So using a Fluent API, which is get API functions, it lists for me all exposed API endpoints. In this case, it is a REST application. So these are all get and post requests that are accepted from consumers or attackers. So these are the points where typically your consumers interact with and perhaps even your attacker is attempting to exploit. So using a Fluent API, we are able to identify your entire attack surface of the application. So I'm going to quickly import So we'll come to this in a moment. Having some technical difficulties with the prompt, but let's come back to this. The next topic of discussion is hunting specific vulnerabilities in your code. I'm going to guide our thinking with a particular vulnerability that's very popular called as zip slip or path traversal vulnerability. Now, as you might have guessed from its fancy name, zip slip is a vulnerability that's all about zip files. In a nutshell, an attacker can create a zip file and use path traversal to overwrite important contents of that zip archive in order to impact or exploit the functionality in your application, which could lead to either destroying or replacing certain critical system files in your host. The attacker might use the ability to target files that can execute remotely, such as parts of the website or files that the computer uses or likely runs. So we're going to ask certain critical questions to identify if your application is susceptible to this vulnerability. And given that we are guiding our thinking, we are going to use this application called StarPit to identify and ask if it's susceptible to zip slip vulnerability. There is a particular web service API called as file uploader. Note that this file uploader accepts a zip file as an input and directly unzips this file into a prescribed location, which is the product source folder. Note that between accepting the zip file and unzipping this file, there is no validation conducted on the entries of this file. So all the conditions in this function directly lead or indicate to the existing symptoms of a zip slip or a path traversal vulnerability. So let us ask a certain set of questions to identify if this vulnerability exists in this code base. Firstly, I'm going to ask if this code accepts any HTTP requests as parameters. Using this API, which is CPG method parameter eval type, I can ask a question if any function accepts an HTTP servlet request as an input, which means that it's an exposed endpoint API that an attacker can potentially interact with. So we've got several here. So now let us further ask this question of whether this particular source can touch an unzip function, which is the sync. and if there is any validation of the content of the zip entries conducted between the source and the sink. So for this, we are conducting the source sink reachability, what we earlier spoke of. Sources are where your attackers can touch functionality or API endpoints in your application, and sinks are where that untrusted input, which is injected or induced by the attacker, can exploit a certain functionality in your code. So given that I've assigned sources to any API endpoints that accepts HTTP servlet requests as input, and sinks are where we are accepting the input and directly extracting a zip archive. So ShiftLeft provides a very succinct flow analysis using the code property graph. So using this very succinct API, which is give me the reachability semantics from a source to the sink. Upon executing this Fluent API, I get a flow. This flow is almost like a business workflow in your code, which is saying that you're accepting a request, you're extracting the zip archive content, and thereafter conducting a series of transformations and finally calling an extract all function in an open source library called as Lingala zip4j. Now, typically, if these transformations between receiving data from the source and calling the unzip function does not contain checks of the zip entry, then you are susceptible to zip slip vulnerability, which means an attacker can send an exploitive payload and take control of your host. So now I'm going to further ask another question, which is if the sink can touch a source, and is it passing through this get canonical path validation function, which means that the engineer is conducting some degrees of checks to ensure that the zip entry does not contain a malicious payload. So it is evident here that the list is empty, which means that the engineer is not conducting any validation. So if I switch this to passes not, which means that the sink is touching the source but is not passing through a canonical path function, it would lead for the vulnerability to manifest. So here we have all conditions that prove that this vulnerability can exist. Now, what I'd like to do is take this information back to the engineer. And for that, I create a succinct representation of the zip, and using our integrated workflow, we can message this back to the engineer as an issue in the GitHub project. Now, the next case that we're going to walk through is an information leakage case, where we are essentially going to use an example that we earlier touched on, which is hard-coded AWS credentials found in this code snippet. And thereafter, these hard-coded credentials are being logged to the log file, which essentially could be sent in clear text to your logging and your SIM vendor like Splunk or Sumo Logic, where your administrators might have clear text view into all of your cloud credentials. So in order to guide this, we are again going to use the example that we earlier spoke of, where we are going to check for hard-coded credentials. So for this, we'll again come back to the console and mark all sources of AWS expression patterns found in the code. So in this case, we are squarely focused on the servlet target function that we touched on. And in this case, there was an AWS access key and a secret hard-coded. So this becomes our source. And we're going to ask a question to identify if these keys are directly leaked to the log file without being encrypted, obfuscated, or redacted. So for this, I mark the literal as the source, and I'm marking all logging functions as the sink. I'm going to just load the console again in a moment. I'm sorry, I'm just having a bit of technical difficulty here. But coming back to this example, what we are identifying is whether we are leaking crowd credentials to the log file in clear text. And if so, are we conducting necessary validation to ensure that appropriate checks like redaction, obfuscation is applied before that data is passed to the log file. And for this, what we can do is execute a very succinct API to inquire whether that data is being passed without an obfuscation function. And I'm going to quickly illustrate that in this API. So given that we codified the log file, what we're effectively doing is checking for reachability from sink to source, passing through an obfuscate or a redact function before it reaches a log file. Now we're going to arrive to the next use case, which is hunting for business logic flaws. Broken or deprecated ciphers have typically known weaknesses. An attacker might be able to brute force secret keys used for encryption, meaning if you're running a business and you're effectively encrypting certain sensitive data like password and storing it in your database, what matters the most is the encryption strength that you use or the cryptographic algorithm that you use in order to encrypt that data before it is persisted in the database. In an event of a breach, most of that data is effectively leaked, and that data is in the hands of a malicious or an adversarial entity. So if it's this case, then the adversarial entity should not be able to brute force all of your data and guess what the password is. Because if he effectively does that, then he can take control or conduct what they call as an account takeover, where he can impersonate your users and begin to exploit their sensitive data. And the reason that the weak crypto needs to be checked is because computational capacity of modern computers permit someone to conduct brute force attacks very effectively and guess what the password is if you're using a weak crypto. So in order to quickly illustrate this case, I'm going to ask if this piece of code that we're speaking of is using a weak crypto. So for this, I'm going to load the graph first because I just initialized my shell. And then check to see if this code is using a weak crypto like DES, triple DES, MD4, MD5, blowfish, etc. So in this case, I'm asking if there are any literals initialized with DES, MD4, MD5, which are essentially weak cryptos and not suggested by NIST and CVEs. The next question that I'm going to ask is if these cryptos are initialized, which means that there is a function typically called as doFinal. doFinal is when you use the crypto and you initialize the crypto in order to sign your passwords or encrypt your passwords before they're persisted to the database. Now I'm going to conduct reachability from source to sink. Now I get a flow trace, and this flow trace is telling me that the engineer is using DES as the crypto, and he's fetching the get instance of the DES and calling doFinal, which is evident that he's using this cryptographic algorithm to sign passwords. And this proves that if any of this data from the database is breached, the data is most likely susceptible to what they call as a brute force attack, which means that the passwords can be guessed very easily, and all of the accounts or your users signed in your database data can be compromised. The next use case that we're going to talk of is what we call as insider attacks. And in order to illustrate this, typically insider attacks are initiated by, like I mentioned, inadvertent insiders are colluding with hackers from the outside or perhaps disgruntled employees. So the use case that we're going to speak of is a scheduled time bomb. A time bomb is a piece of malicious code that executes when a specific trigger condition is met. A typical example would be that a program monitors a company's payroll system and attacks the company if a specific employee is terminated. A time bomb is a type of logic time bomb that uses date and time as its triggering function, meaning when the date is met or the time bomb is detonated from the inside, it might crash your application by performing either a denial of service, or it might potentially delete critical data or degrade the response time of your system. So let us walk through this code base that contains all the symptoms of the time bomb. We'll use the same example, tar pit in this case. And as we examine this piece of code, there is a time bomb embedded in this code that triggers if a time condition is met. So as a part of this workflow, let us draw attention to this function called as ticking. Ticking takes two calendars instances into consideration, and it compares the current time to the future time. And if that condition is met, it effectively executes a command, which is this exec pattern. And if I traverse to this exec pattern is effectively a base 64 encoded pattern. So it's very hard to guess what this exec pattern could be if you are effectively doing code reviews, because it's base 64 encoded. It's hidden from the eye of your code reviewer. So let us examine how we can identify this condition using Ocular. So I'm going to ask a few questions. First of all, is any engineer using runtime.getRuntime.exec function? This is often a bad code pattern, which could raise suspicion of whether there is a potential time bomb in your application. So obviously, yes, we got back a response that the ticking function is using runtime.getRuntime. Now, let us further ask if any input can influence this function. For that, I'm going to ask the full name of the method ticking, which accepts an input, which is a string that influences this particular execution path. I'm going to mark the runtime.getRuntime as a sink, and thereafter I'm going to conduct reachability to identify if a source can touch a sink in this case. Obviously, yes, we got back a response that indicates that a parameter injected, which is a time function influencing the calendar, is causing this method to trigger the runtime.getRuntime. So this is the first condition that exists in the code that proves that a potential time bomb condition exists in this function. The next inquiry that we're going to conduct is whether there are any calendar instances being compared within the scope of this function ticking. And for this, I'm going to first check whether the calendar function set is being called in this function. For this, I'm going to, again, call upon this Fluent API, which is CPG method full name caller. And yes, I've identified that the ticking function is using a calendar set. Again, the next call is to mark or assign the calendar set function to a source and check to see if there's a comparator, which is calendar after being executed based on the source input received. Thereafter, we conduct reachability analysis, meaning is a calendar instance being initialized and influencing this comparator? So obviously, yes, we got back a stack trace, which indicates that we have a calendar function being initialized. So based on this, it's obvious that first of all, we have runtime.getRuntime in this code, which we identified using the flow, which is influenced by the input. And we have a calendar comparator being conducted within the scope of this function, which are the two symptoms that essentially leads to the fact that there is a time bomb executed within the scope of this function. So with this examples, we have demonstrated the ability to conduct interactive inquiries over your code base to extract insights related to vulnerabilities, business logic flaws, information leaks, and insider attacks. And all the results produced, like these stack traces or flow traces, can be exported to your GitHub, Jira, or any other system where you're conducting triage, and using that triage to influence your build decision. These inquiries can be imported also into the ShiftLeft policy engine to conduct continuous and automation verification of your CI/CD pipeline using a product of ours called as ShiftLeft Inspect. So the ShiftLeft comprehensive workbench provides a single glass pane for your AppSec team member to actively collaborate with developers, SecOps teams, and research teams to maintain an effective application security posture across the entire organization. To register for a free trial, please visit www.shiftleft.io. Thank you. I'm happy to take any questions.
Great, great. All right, we've gotten a couple questions in here so far, but there's plenty of time. If you have a question for Chetan, please go ahead and use your GoToWebinar control panel and submit your question, and we'll go ahead and get to as many as we can. First question, let's see. What is a dependency for this tool? In which language is it developed?
The dependency, this particular tool or this interactive command line tool is developed upon the foundation of Scala, which means that you have the power of Scala programming languages to essentially create your own scripts. But ShiftLeft CPG currently works with any program written in Java or .NET, which is C#. We will soon be supporting Python, Golang, and Node.js as well.
All right, great. So the next question is, how is Ocular different from SAST? S-A-S-T.
Absolutely. A SAST is squarely focused in identifying vulnerabilities in a particular application. But Ocular is an interactive system that lets you conduct inquiries over your code to not just identify vulnerabilities or symptoms leading to vulnerabilities, but also business flaws, insider attacks, and information leakage as well. So the advantage of having Ocular is you can effectively conduct inquiries in a stepwise fashion and compose all of your inquiries into a script and then execute your script continuously in your CI/CD automation.
All right, great. Next question. How is weak encryption a business logic flaw?
Great question. The weak encryption is typically an architectural flaw, which is quantified in what they call as a CWE or common weakness enumeration. But this architectural flaw could effectively manifest as a business logic flaw, because if weak crypto is used to encrypt your sensitive data, and that sensitive data is persisted and at some point in the lifetime breached, then that data is available to an attacker to conduct brute force attacks, given that the weak crypto enables him to quickly guess what the password might be, or any other sensitive data that is decrypted might be.
All right, great. Okay, next question. Do you have any other examples of business logic flaws that Ocular can help with?
Absolutely. There are several classes of business logic flaws, and given Ocular lets you identify symptoms, you can identify or check for authentication bypass, meaning that in certain cases, engineers want to effectively debug and bypass compliance. So they effectively embed a secret key and evaluate for the secret key by bypassing typical validation set forth by the organization. So that is one use case. And there's several other use cases, and each of these use cases has symptoms behind it. So Ocular effectively lets you create scripts to codify these symptoms and validate for these existence of the business logic flaws.
Okay. Okay, next question. If I want to implement DevSecOps in my organization, how does having Ocular help?
Great question. So the typical DevOps practice is a joint responsibility where the AppSec teams owns the security posture of your application, where they embed necessary security measures in the CI/CD process to gate any code that is not meeting the set forth criteria by the organization. So Ocular, combined with ShiftLeft Inspect and Protect, provide the ability to, first of all, create targeted recipes or policies that are specific to your organization from a security perspective, and also go beyond common vulnerabilities to measure for business logic flaws, inside attacks, and information leak, and combine all of that into policies which is baked into your CI/CD process to continuously evaluate and measure for lacking security posture as you build applications in your pipeline.
Excellent. All right, great. Still time for questions, guys. If you have one for Chetan, please go ahead and submit it via the GoToWebinar control panel. Our next question, do you model exception handling as part of control and data flow?
Yes, we do.
Okay.
I have another question. The insider, let me quickly repeat this question. The insider scenario is insanely obvious. In what threat model is the insider is really, I didn't get the last part, but to your point, typical insider models are sometimes obvious and sometimes not. They are a combination of certain conditions that are seeded in the code to escape pure code reviews and typical code scanners. In certain cases, they are obvious, and the cases that they're not obvious is when a particular malicious insider might essentially base 64 decode or encode the payload so that it escapes typical pure code reviews. And in the flow, as that particular encoded input influences a sensitive sync, he might conduct a decode function. So all of these conditions should be measured in unison to identify if there's a threat from an insider perspective that might exist in the code.
Excellent. Okay, great. Moving on to the next question. Is there any chance to get, let's see, is there any chances to get UI in the future? And then does it generate a report? This is a multi-question question. And can we integrate this with our existing CI/CD pipeline?
Definitely. Quickly draw your attention to this the slide. Yes, we do have a UI. What I just described from an Ocular perspective, we have the capability of taking those inquiries, converting them to policies, and continuously evaluating them in your CI/CD pipeline. And all results that is created as a consequence of vulnerabilities is manifested in a dashboard in our ShiftLeft Inspect product. The next part of the question is, does it generate a report? Yes. We have the capability of generating a report and exporting that report that can be consumed either by your SIM or by any other subsystem like Jira, Bugzilla, etc. The third sub-question was, can we integrate this with the existing CI/CD pipeline? Yes, you can. We provide a very simple and comprehensive command line tool that you can call as a post-build step in your build pipeline, which conducts this evaluation and extracts these insights. And using these insights, you can effectively conduct triage and conduct prioritization of all vulnerabilities detected in your code.
Okay. All right, great. Let's see, next question. How much will this ShiftLeft agent, or I guess Ocular agent in production impact the server performance? Is there any data available?
Yes, we have data. We're happy to share that data after this webinar, but our analysis, as far as our analysis is concerned, we can analyze over 500,000 lines of code in less than 10 minutes. So typically your DevOps pipeline comprises of building your artifact, conducting a series of validations and verifications, and then making a decision of whether the application should be packaged and deployed or not. So depending on the complexity of code, our system is optimized to effectively analyze large code corpora in a matter of minutes. So we do not impact your typical build process. And given that the results can be exposed and consumed, all of this is done really fast in order to abet your build decisioning or your deployment decisions as well.
All right, great. Gosh, we've got some really great questions in, guys. I'm really impressed by these. Next one, when you talk about .NET, do you also mean .NET Core 2.1?
Yes, yes.
Okay, excellent. All right. Next question. Sorry, did you want to add, expand
please
on
go
that?
ahead.
Does Ocular use CVEs to identify vulnerabilities in open source libraries?
No, actually, Ocular goes beyond CVEs because CVEs typically quantify known and announced vulnerabilities, but behind CVEs are a series of symptoms which, when exist in collective, lead for a particular vulnerability to manifest when an exploit is applied to it. So Ocular lets you query and identify for these symptoms, which means that you can go beyond known vulnerabilities and also identify unknown vulnerabilities that might exist in your code.
Okay, great. Next question. It seems your headquarters is in Australia. Do you have an office in the United States?
I'm afraid not. We are not headquartered in Australia. I wish we were. We are we are headquartered in Santa Clara, California.
Ah, okay. All right.
So if you go to www.shiftleft.io, you will get all the necessary detail associated with our company.
Okay, great. Let's see, we have a couple minutes left for questions. If you have any last minute ones you want to throw in, go right ahead. And let's see, the next question. What about integration of the CPG queries results to import them in DSE Cassandra and further analysis by Graph and Gremlin scripts?
We have already done all of that hard work for you, meaning that we have built our own optimal graph representation of code, which is both memory optimized and disk optimized, so that you can leverage the ability to query these complex patterns and essentially focus on identifying vulnerabilities. So to answer your question, we have done all that hard work for you, and all you have to do is query.
All right.
There's one question that I'll quickly take. How is Ocular different from SonarQube or code analysis tool? Ocular is a unique software tool as compared to SonarQube or code analysis. SonarQube is typically squarely focused on vulnerability management, meaning that they provide an interface that lets you take results from various scanners and bring them to a single glass pane. And most of the time, they're focused on vulnerabilities that is defined by the OWASP category. Ocular is an interactive tool that lets you query for symptoms that could lead to inquire for the existence of vulnerabilities, backdoors, business logic flaws. So from a use case standpoint, it is broader than a typical vulnerability management tool or a code scanner.
Okay. All right. I think we have time for one more question, and we'll have to close it out. After I write a query I'm happy with, can I enforce it as policy on future releases?
Absolutely. Absolutely. As what you see on this presentation at the moment, any policy that you create can be embedded in our continuous evaluation process in your CI/CD pipeline, which means for every release of your code, that evaluation can be repeated.
Excellent. All right. Great. Well, that is all the time that we have for questions, but I do want to thank everybody who did submit a question. And if we did not get to it during the Q&A session, I apologize, but please know that the folks at ShiftLeft will be getting a copy of all of the questions. So I'm sure they'd be more than happy to follow up with you offline post-event to get your question answered. Let's see, I know we have a gift card drawing that we need to do, so why don't we go ahead and do that now before we close things out. And okay, we've got our first winner here of the $50 Amazon gift card is Andriy Tomchuk. Congratulations, Andriy. Our next winner is Donald Smith. That's an easy one. Congratulations, Donald. And next winner of our $50 Amazon gift card is Martin Simlastic. Martin, congratulations. Our fourth winner is Richard Brunner. Brunner, yes. Okay, congratulations, Richard. And then our final winner is Sean Jameson. Congratulations to everybody who won. We'll be contacting you offline to coordinate the $50 gift cards to you. So again, congratulations. Before we close things out, I do want to remind everybody that today's event has been recorded. So if you missed any or all of the event, or if you just want to listen to it again, you will have the opportunity to do so. We will be sending out an email post-event that includes a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website, so you can always find it there. Just go to DevOps.com, check the webinar section on demand, and it should be right there waiting for you. And then while you're there, please take a look at all the other webinars that we have, both upcoming and on demand. Hopefully there will be something there that piques your interest. Chetan Conikee, thank you so much for a great presentation. I know judging from the questions we've received, I know the audience got a lot out of it, so appreciate it.
Thank you, Charlene. Great. I'd encourage all the attendees to visit www.shiftleft.io, try Ocular, and experience it for themselves. Thank you.
Awesome. All right, great. I do want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.